Hi and welcome back to Master Your Science. So we're going to continue looking at physics paper 6, and this question is also another typical example of how you can actually get away with just having good mathematical skills is enough to answer this question and get most of the marks. So it's only about 2 marks that you may lose, but actually you can still get those 2 marks because they just require your critical thinking. So let's dive right in. Number 3 says a student investigates the magnification produced by a converging lens. He is using the apparatus shown in figure 3.1. The illuminated object consists of a triangular shaped hole in a piece of card. Figure 3.2 shows full size the illuminated object. Measure and record the height h0 of the triangular shaped hole. So h0 is indicated on the diagram, so we'd use our ruler to get this height here. So that would be 1.4 centimeters. And then part B says the distance between the illuminated object and the center of the lens is set to u is equal to 20 centimeters. The screen is moved until a focused image of the illuminated object is seen, as shown in figure 3.3. The student repeats the procedure for u is equal to 30 centimeters, u is equal to 40 centimeters, u is equal to 50 centimeters, and u is equal to 60 centimeters. His results are shown in table 3.1. Measure and record in the first row of table 3.1 the height h1 of the image. So again, you're using your ruler to measure h1 here, and this height is required in centimeters, so that's 4.5 centimeters recorded here in the table. Then using your results from A, and our result from A was h0 is equal to 1.4 centimeters. And the equation m is equal to h0 over h1. Calculate a value m and record this value in table 3.1. So h0 would be 1.4 divided by h1, which is 4.5, and that gives us 0.312. So that's 0.31 to 2 significant figures. So our table is now complete. Then moving on to the next part of the question, it says plot a graph of u in centimeters on the y-axis. So here we've got on the y-axis we've got u in centimeters, and then on the x-axis we've got m. You do not have to start your axis at the origin. So if we come back to our table, our values for u range from 20 to 60. So you can actually just start from 20, since we don't necessarily have to start from 0. So you can. Alright, so I'm just going to use an improvised grid to show how we draw the graph. So this is our y-axis, this is our x-axis, and the question has already told us we're putting u on the y-axis. So we've got u in centimeters on our y-axis, and then we've got m on our x-axis. And kindly note that m doesn't have any units, because when you calculated m, it was h0 over h1, h0 being in centimeters and h1 also being in centimeters. So the result, which is m, would have no units. So the other point that was made was that the origin doesn't have to be 0, 0. So in our case, for u, we have a value of 20, 30, 40, up to 60. So for u, we can actually start from 20, which means and here on our y-axis we can have 20 as the start value, then 30, 40, 50, 60. And then on our x-axis we've got values ranging from 0.31 to 2.8, so 0.31 up to 2.8. so we need our values to be up to around 3. So the important thing is just to make sure most of your grade is occupied. So in this case we can for x-axis we can start from 0, then the next digit can be 1.0 and 2.0, 3.0. so that's our x-axis. Now we need to plot our points on the graph. So the first point would be 20 against 0.31. So we've got our 20 here, and then 0.3 would fall somewhere here, but then 0.31, so it's just slightly over there. And then the next point is 30 against 0.93. So 0.9 would be somewhere, so that's the next point. And then the next one is 40 against 1.6. So we've got 40 against 1.6, so that's 1.6 would be here. And then we've got next point being 50 against 2.3. So we've got our 50 there, and then 2.3 would be here. And then the next point is 60 against 2.8. So that would be our last point. So just by looking we can see that this is a linear graph. So I have to put our line of best fit there. So I've used my ruler to draw the line of best fit there, and as you can see these 2 points are not quite on the line, but it's a line of best fit. And also remember, this is an improvised graph, so it's not quite as accurate. And then so the main things when drawing the graph is we've got our x-axis and our y-axis. They are properly labeled using centimeters. M doesn't have any units. And we've got a reasonable scale for our y-axis and our x-axis, and our graph occupies more than half of the grid. And then after we've drawn our points, we've got a line of best fit. And then the next question wants us to calculate the gradient of this graph. So now we just have to pick a point, like pick points to draw our triangle to get our gradient. Okay, so I've picked these 2 points to get my gradient. So this is my triangle, and then for our gradient we'll need our change in y and our change in x. So our gradient, actually we've been given gradient as capital letter G, would be equal to our change in y over our change in x. And from our graph, our change in y would be this y value, so that would be 44 minus this y value, which would be 34, over then our change in x, so that would be 1.8 minus this y value, which is approximately 1.2. So that gives us 10 over 0.6. Okay, so we've shown on our graph how we managed to get the value of g. So it was 10 over 0.6, which gave us 16.7. So that would be 17 to 2 significant figures. So that's the value of our gradient. Then the next part says, describe one difficulty that might be experienced when measuring the height of the image H1. Suggest an improvement to the apparatus to reduce this difficulty. So one difficulty that we might face is that it might be difficult to accurately measure the height of H1 because it is too small. So how we can improve that is to use a bigger object with and have that much bigger, so that we can measure H1 much more easily. Another difficulty would be that if you were trying to measure, you might actually cover the space where you're trying to measure and you're not able to actually see properly what it is you're measuring. So one way would be to just mark the points where the image ends and then measure afterwards. So those are the possibilities in terms of answering that last question. Let me know if you have any questions.